No. So I'm going to make it a nice, super negative number. What's the upper bound? This is why you want a z-score. What's the upper bound of that shaded area?
Negative 0.6. Yeah, repeat.
Negative 0.6. Repeating. Now, I think there is a way to put the repeating in the calculator, but I'm not even going to do that. I'm just going to put it as a fraction. What was the 50 minus 54?
Negative 2 3.
Well, negative 4 divided by 6, which you could convert to negative 2/3, right? But literally, I'm just going to write it as a fraction. And because I'm dealing with z-scores, dealing with the standard normal distribution, what's the mean? What's the mean for the standard normal? 0. Remember, the z-scores come from the standard normal distribution. And then what's the standard deviation of that standard normal distribution?
1.
And so what does that equal?
I mean, isn't it 0.2546?
Is it, or does it give you the same?
Oh wait, no. 0.252492.
0.2524?
92.
So 4 decimal places is 0.2525? Rounding it?
Yeah.
You just said 0.2524.
What?
It's 249.
From the table it's 0.2546. From the calculator it's 0.2525 once you round it to 4 decimal places. Okay? And so, are they close?
Yeah.
They're close enough, right? They don't really start to deviate until the thousandth place. So that's good to note. Okay, from here, don't forget that's just an area. What's the percent?
25% or 25 point.
25.2.
Well, from the table it's 25.46%. From the calculator, 25.25%.
Yeah.
Okay. Yes, Guy.
Can we have also rounded hundreds, please?
Well, if you're using the calculator, don't round.
I'm saying from the table.
No, so like for the area, always go to 4 decimal places for that area. Are you talking about the z-score? You have to have rounded the z-score to the hundredths place. Notice, for my z-score I did negative 0.66 because I can't go beyond that on the table.
You can go 0.67 because it's repeating 6.
Good? It's your choice. I would accept either.
That's all I'm saying.
Okay. Alright. Now I need y'all to pay attention to this next one because the next one is a little bit trickier. Not much. What do you think we're going to do first for this next one? Get those z-scores, right? Well, but to get the real curve, I need to get those z-scores. Emma?
So what did you do, 16 minus 12?
What?
So you throwing.
Number 7, right?
Yeah.
What'd you say?
16 minus 12.
Where are you getting 16 from?
So I'm getting it from the chart. It's up there.
But
There's 16.
I don't see where you're getting 16. Remember, we're trying to find the percent of hybrid cars that get between 50 and 60.
Yes.
But
So-
how do, hold on. Those are the values.
Yeah.
How do we calculate z-scores?
Well, like you did up here, there's 50 minus 54 divided by 6.
So z would be 50 minus 54 divided by 6. So the lower bound would be negative 0.6 repeating.
Yes.
Okay? So then what's my other z? I don't see where we're getting 12 and 16 from because the value is going to be 60, right?
Sure.
Not sure. Look at the problem. We have 50 between 50 and what? 60. So what's the second value? 60. Isn't that the second value?
Right.
Minus the mean, which is still 54, divided by the standard deviation, which is 6. Does that make sense?
Yeah.
Okay. So I'm trying to think about where you got those numbers, and I'm just not sure.
Okay, so from I got 12 by getting from the 12 numbers from the first 3 rows. So if you ignore the 0.3 on the bottom, there's 12 numbers. And all of those are less than 60.
You're looking at areas though.
Okay.
We're looking still at the miles per gallon.
Okay.
So one of the things that I was pointing out to somebody else earlier is we are looking at the normal distribution to start with a mean of 54 and a standard deviation of 6. But we don't want to deal with the normal distribution, we want to deal with the standard normal, which is based on z-score. So what is this z value? 1. So I'm converting these values to z-scores so that when I shade, I have a mean of what? What's my mean? 0. And I go from, well, the upper part is 1. And this lower part, not -1, -0.6 repeating, right? I'm looking in between there. So notice those are the 2 z-scores I have, right?
You explain this for number 7, or you just explain the other?
Number 7.
Cool.
Right, because I've got those values of 50 and 60. I get my z-scores of -0.6 repeating in 1. And so so notice we have 3 different regions. What's below, what's in the middle, and what's above. Which of those sections am I looking for the area in percent? I'm looking for in the middle, right? It's between 50 and 60. So I want all of this. Use your calculator, find that area. I'll come back and show you how to use the table in a minute. With that, Selena. 1, it's too late for that. 2, this is literally the first time you're looking at this. You were freaking out about the, stop. Selena, not everybody gets it. That's something you're telling yourself to tell yourself that you should give up, and that ain't true. No, Selena. What do you tell me when you walk into this classroom every single day? I am capable. There's no buts. You are capable. Quit giving up, and let's do the work to learn. No, you ain't. I won't let you.
Strive for greatness. Well, I don't know what I'm doing.
Then keep trying.
Lower bound, what?
That's not what the answer to the problem. So you don't want to do the area yet. What do you mean you got the answer to the
No, let me try first.
I understand you're talking about 7. That's not how that works. You got to look at the lower z-scores, but you can't have the upper score.
Where'd I get that from?
Like, show me where you're looking at this table.
You're still using this?
That has nothing to do with
Okay, so what's the value?
These are z-scores. You still need the z-scores to get to that area. Pick up your calculators, guys. Yes, ma'am. Look at that graph. What's the upper part of that z-score?
Exactly what he wrote.
Why?
And the lower bound is not -1. So there you go. Thank you. Thank you. Hey guys, look at the graph again. What is the lower bound to that shaded region? -0.6 repeating. That's why you shade. The lowest part of the shaded region is -0.6 repeated. What is the upper part? 1. Do it as a fraction for the, no, what did we just say the lower bound was? -0.6 repeated, right? So remember, I went through as a fraction. That's not repeating, right? We got that because there's -4 divided by 6. So type in -4 divided by 6.
How do I know it's left for what?
6, right. The upper bound of that shaded region. Right. That's it. Don't make it harder than that.
It's still fairly quick. Yeah. Instead of the
Thank you. Okay. So, again, guys, we're just looking from that lower bound to this upper bound. So what we should have, once we look at the calculator, we typed everything in, normal CDF, negative 2/3 or negative 4/6. Remember, I'm just going to do it as the fraction is there. If you know how to simplify it, go for it. But you don't have to. You can just do negative 4/6. That's my lower bound. Where does it stop? At 1, comma. The mean is 0. The standard deviation is 1. 0.5883, I think is what I heard.
Okay,
85, my bad. Or what percent?
58.89.
89?
Because it's 5,888.
No, it's 5.
5, 2.
Oh, 5, 8.
There's 3, 4, 8.
And then it would round.
Yeah, it rounded
So-
up.
It would round to 9. Got it.
So what at 1 and 0 and at 1.
So then 58.89%.
Because the zero is the mean and the one is
Okay, so
total of 60 minus 4.
when is your tutoring?
So when you just figure.
For real? No, I'm fine.
Look,
I'm not joking.
that's one.
Yeah.
Monday, Wednesday.
Man, I had to be here Monday.
Say again, Gabby. I can't hear Gabby. Excuse me. That's what we're about to look at. Okay? So, here's the thing. So first off, I do have the tutoring. Remember, I also have the videos on YouTube where I explain it. You can skip the part where students are in small group discussion. Just focus on the explanations. So here's how we do it on the chart, okay? Here's what I want you to recognize. The table only gives you the area to the what? Area. Remember, if I look at a z-score of 1 on the chart, it's going to give me the area to the left. So if I look at the z-score of 1, it's going to be from, that doesn't work. It's going to be from a z-score of 1 all the way to the left. Do I want all of that though? No. What would I need to take away so that I only get this section? Was everything is below that negative 0.6, right? If I look at negative 0.6 on the chart, isn't that going to give me all of this area? So then I would take the area from here and subtract out the area from here. That's it. So I'm going to find the area below z equals 1 and then subtract out the area below z equals negative 0.6 repeating. And this is especially where I prefer the calculator over the table. So here is the table though. Its value of 1.0 would be, so So 1.0 is here, 0 again is here. So what is the area to the left of 1? So then that would be 0.8413 minus, I need a z of negative 0.6. And then Kaya, you could do 6.7 or 6.6. I'm good with either one. So there's that minus 0.2546. Right, so it's just the area below z equals 1 minus the area below z equals negative 0.6 repeating.
Oh.
0.5867. And what's that percent? So it's not exact, but is that pretty darn close? Yeah. That's all it is. Personally, I'm going to go with the calculator for a problem like that. The table's really good when you're looking for just area to the left or just area above. The calculator is always easier. Or is always easy. Okay. What are your questions?
I understand this.
I'll be here.
That's not a question.
Can you help me understand this?
What part of this is giving you trouble?
All of it.
That's not a question.
That's the answer.
That's not, you're not thinking, you're just trying to give up.
Okay, no, I'm really trying not to.
Okay, so
Mommy,
mine help me get the part of the part of finding the z-square.
Okay, so you know there's a formula for the z-score.
Yes.
It's just your value minus the mean divided by the standard deviation. That's it.
I got that.
Then what's the confusing part? We get this.
How you plugging in the numbers for the z-score?
Yeah.
Like, what's the value?
That's the value. How do you what? I'll put this in the calculator. That's it. Like y'all are making that way too hard. Guys, look.
You want to do that?
50, no ma'am. 50 minus, because here's the thing, y'all are freaking out about calculations. You got a calculator for calculations. I need you to focus on what does the z-score mean and how to get the area. That's it. Y'all are freaking out about calculations. Now, 50 minus 54 is -4. -4 divided by 6 is that number. It's -2/3. But why are you freaking out about that? You've got a calculator to do calculations.
Okay, so, right there, normal CL, you will plug in, what? Hold on, wait.
You're not plugging in, so look, you go to your calculator, you hit menu, you go to probability or statistics, you go to distributions, normal CDF. It walks you through it. If you have the graph done, the lower part of the area is -4/6 or -2/3. The upper part is 1. The mean is 0, standard deviation is 1 because it's the standard normal curve.
See,
Do you have to put the decimal form and fraction form?
If the decimal's repeating, yes.
so how you
How you put it if it's repeating?
You just put it in fraction.
You put it as a fraction.
You gotta get a
They
fraction
put
for
it in
the
repeating score, so you just put it in fraction.
So where did you sell the question?
Fractions?
Okay, I'm going to address this when I start the next part of the class, okay? For the next part of the lesson. Okay. So, eyes up here, we're going to get some more practice with this by looking at what's called a percentile. So here's what I need you to notice. Alright? You may have heard someone say, hey, my baby's weight is in the 90th percentile, or my student scored in the 80th percentile in math. The percentile is an important idea associated with these normal distributions, or just distributions in general. A percentile is a data value for which a certain percent of the data is below that data value. So when we talk about percentiles, percentiles are always what is to the left. So if you have someone that says, hey, I'm in the 80th percentile, and you'll see this on your ACT scores, you'll see it on the SAT, PSAT, all that stuff. What that means is 80% of the data or the people scored below you. If you have the 90th percentile weight, then that means 90% of babies have a lower weight than that baby.
Does that mean baby fat?
Not necessarily, because they could be taller as well.
True.
Right? Because I have a friend whose baby was literally in the 99.9th percentile in weight, but they were also in the 99.9th percentile in height. So it's proportional.
That's what it
They're a big family, okay? All right.
Oh, it's not, so he meant like big.
You mean like,
Number one, this is going to help us by looking at going the opposite direction. All right? So the number of text messages teens send and receive every day can be represented as a normal distribution with a mean of 100 text messages per day and a standard deviation of 25 text messages per day. What we are looking at right here is the 50th percentile, and I need you to pay attention to this. The 50th percentile, would that be a z-score or would that be the area?
Area.
That's area. Percents and areas go together. So what is the area with this 50th percentile?
50.50.
So 0.5. Okay? If I have the area, what do I need to figure out? I need the z-score for that area. Did I put the z-score before? Okay. So you would have to search the table for that or for that area. Where is that area?
In the middle. Wait.
Give me a value.
Oh, I thought you were
Give me a z-score.
265.
If I go to 1.0, that area is 0.8413. Oh, if I look at 0, 0, a z-score of 0, what's the area there?
0.5, 0.5.
Okay. That area of 0.5 goes with a z-score of 0. Okay? No, so remember, they want the 50th percentile. The area for the 50th percentile is 0.5. And then I use that to find my z-score. So 50th percentile, that gives me my z-score. And from there, I can figure out the value from the data set. Yes, Madison?
Where you find that at?
We're on the table, bro.
No, I'm looking at the table.
Okay, you know the area is 0.5, right?
Yeah.
You see right here where it has an area of 0.5?
Yeah.
What's the z? 0 and 0, so it's 0.00. Remember, you go to the edges to get the z-score.
True.
Okay? So here's how you would find the value of that person, right? So we have a mean of 100 text messages, a standard deviation of 25, and we know that the z-score is a value minus the mean.
Divided by the standard unit.
Okay? Now I will say the z-score is 0, which means we're looking at the what? The mean. If the z-score is 0, we're looking at the mean. And what's the mean? 100 text messages. But we can also set up this equation, because we now know z is 0. We are trying to find the value. We know that the mean is, what's the mean?
0.
Wait, is it open?
Remember, it's the mean for that data set. The z-score was 0. The mean is 100 based on this information, divided by the standard deviation of 25. And now what can I do to solve that equation?
Calculate.
Okay? So what would I do to solve though from this point? Right? How would I do that?
Multiply 0 by 25 in the other.
Well, so one thing I want to pause. I'm not even going to focus over here. I want to cancel out the division by 25, right? So I'm going to multiply by 25, because what's 25 divided by 25? 1.
Oh, I'm thinking of 100.
Whatever I do to one side of the equation, I got to do to the other.
100.
0 equals x minus 100.
You add 100 to both sides. You get x by itself. 100.
Oh yeah, is that exactly what we just predicted? That the value would be 100 text messages? So
Somebody tell me no kid.
the person sends 100 text messages. Now,
Zero.
say again.
Can you read my explanation?
That person sends 100 text messages.
No, not that.
What?
Yeah. Can you read the
Well, I'm using my inverses to cancel out these operations. I'm dividing, right here is division by 25. So the inverse of that is multiplying by 25, and 25 divided by 25 is 1. And I have to do it to both sides for those properties of equality. But 25 times 0 is 0, and 1 times x minus 100 is x minus 100. I add 100 because that creates a 0, and I have to add it to the other side to balance it out. So 100 is equal to x. Okay?
Not like that.
All right. That is literally the way you solve the equation, guys. Use inverses. Okay, pause, listen, stop. For those of y'all who had a question, just pause for a second after class. I'll be more than happy to answer your questions so that you don't leave here confused. Just so you know, we are going to wrap up at lesson 3 on Monday and start lesson 4, which means we'll end new content on Tuesday. You do have a homework assignment that will be due on Monday. It is 2 problems. It's only from lesson 2. It's not this lesson. You have a homework assignment, lesson 2 that's due on Monday, and then I will have to make this due on Wednesday. It will not be due on Tuesday. These 2 problems will be due on Wednesday.
Oh, just say capital.
Is what? Yes. That is what you'll only be doing Monday. Have a great rest of your day and a great weekend. Okay. Over here.
College, keep the drunk. Keep the man.
Don't look at me though. I'm about to kick you. Yo, ladies don't be trying to wait on nobody.
Sleep. Oh, so you don't understand how I'm creating threat. Okay, so here's the thing. When we have what's called a standard normal distribution, see here, it is that normal distribution, right? The standard normal distribution is a special one that is centered at 0. The mean is always 0. And the standard deviation is always 1. So remember, the standard deviation can be found where you can go from the concave down to being concave up. You see how it changes almost a shape there? So that's one standard deviation. That same distance gives me my second standard deviation. That same distance gives me my third. And remember, this is how we get the empirical as well. Right? So then here, well, so the whole area is 100, but what the empirical rule actually tells us is that between 1 standard deviation below and 1 standard deviation above is 68% of the data. Between 2 standard deviations below and 2 standard deviations above is 95% of the data. And then between 3 standard deviations below and 3 standard deviations above is 99.7%. And it's based on this that I'm then able to graph these z-scores, right? So that's how I got this 1 here, because that's that point of inflection. And that's how I got this -1 there, which allowed me to estimate that z-score on the graph. Yes, go right ahead. Zara, did you have a question?
I was going to actually call you today because I needed some help and I was trying to get in my group to talk to me about it. And one of them were just saying you need to pay attention, but I was trying to figure it out and I didn't really understand it, but now I'm kind of getting there a little bit. But I was I felt embarrassed because if I called you over there, it would kind of be unnecessary.
Well, I mean, you can't be afraid of that, but what I would also say is, to a certain extent, I understand.